Hello everyone, welcome to this week's lab. So this week we will learn the basic vector data analysis. So those are the fundamental spatial analysis that we will use a lot in ArcGIS Pro. So I think the best way to learn those analysis is through a project. So we are actually also doing a very small project. So we're going to investigate the mass routine data in the United States and also see how the data are related to the population data. So let's first create a new map project, and let's call it Lab 7. We're going to save the data to OneDrive folder. So this is what I always did for this lab. So if you are wondering why we want to save data to OneDrive folder, and that is because the data will be always uploaded to the cloud, and also if you switch the computers, as long as you have the access to the OneDrive, you will be able to open your project by using ArcGIS Pro in your OneDrive. Okay, so let's start this project. And we're going to download two datasets. And the first dataset is 2023 mass routine data in the United States. So in our last lab, we geocoded those data. So in today's lab, you're going to use my data that I uploaded the geocoded data to ArcGIS Online. So we go to Portal, and we're going to ArcGIS Online, and then we're going to search 2023 mass routine and hit enter. And we see we have a lot of dataset that calls mass routine 2023. And the best way to find out the right dataset is to look at the owner name. So make sure that you are using the data that is uploaded by WEIXX_GMU. So that is my user account. So let's drag this dataset to our project. I already defined the pieces for this dataset, so we don't need to define it one more time. And you can see that the map has been changed. The coordination of the map has also been changed. So let's also export the data to our local geodatabase. I think it's a good idea that we keep everything in our project geodatabase. So let's give it a name. Let's call it mass shooting. And for the fields, we just need the incident ID and also number of people being killed and also injured. So we don't need the other fields. So you can see those fields are created through the geocoding process in the last lab. So I'm going to select the first field, and then I just go down and find out the field that's just above the incident ID. I'm going to hit Shift key and click. So now you can see the multiple fields has been selected. So now I just click this X so to remove those fields. And we will keep the ID. We will also keep the date. We don't need the state. We don't need the county. We don't need the address. We want the number of people being killed and also injured. We don't need the other three fields. Okay. All right. So that looks great. So we give the name mass routine, and we just keep those fields that we need. Let's just click OK to export the data. And now if we go to our database, and you can see mass routine is already here and also has also been added to our map. All right, next we're going to download the population data. So in the previous lab, we download data from the census website, and we joined the non-spatial data with a Tiger shapefile. You can do that, but there's also another quick way, which is you go to the portal. And this time we're going to use the Living Atlas, which is the data that is maintained. Most data are maintained by ESRI. And then we search population. We're looking for the first one, which is ACS total population. And you will see that that is maintained by ESRI. So that's a very high quality data set. And if you click that URL, you will be able to see the more description on their website. So let's drag this dataset to our project. And this dataset contains the population data at different levels. So if you expand the data set, you can see they have the population data at the state level, at the county level, and at the census tract level. And also they have the population data in different age groups. So we just need the total population variable, and also we just need the state name and also GEOID. So let's right click the state, and let's go ahead and also export the features. We gave it a name, let's call it state population. And for the fields, let's keep the GEOID, and let's also keep the name, and let's also keep this field. So if you remember, this is the table name for the total population. Let's remove all the other fields. So use Shift key and also remove. So we just need GEOID, state name, and also total population. And for this data set, we do need to define the PCS because this data does not contain PCS. So the quickest way to define the PCS is that we will click this drop-down list. We see we want to use the same PCS as our mass routine data set, and which is this one. And that looks nice. And let's just go ahead and also export. So it will be saved to our geodatabase as well. Let's do the same thing for the county population. So that the population data at the county level. We are going to do the same step. So we're going to the same step. So we are going to see that the county population for the fields. Let's keep the GEOID. Let's keep the name and state. Let's also again keep the total population. Let's remove everything else. So Shift key and auto remove. Don't forget to define the PCS. So because some spatial analysis require a PCS. So again, we see we want to use the same PCS as a mass routine data set. And that looks nice. And we just export. And once the data has been exported to our geodatabase, we can just remove the other the data that we just dragged from the ArcGIS Online or Living Atlas. All right, so let's remove the data that we don't need. So we keep the mass routine data, the population at the county level, and also the population at the state level. And if we go to the project and see that in our geodatabase, we have those three features. Let's also save our project. So save the project. All right, so now let's start our analysis. So I'm going to uncheck the population at the county level. So our first question is that, so at the state level, we want to count that how many people were killed or injured in each single state. So for example, that in Virginia, we now know that this is a state of Virginia, and we have those mass routine instance, and each single point contains the number of people being killed and also injured. So we want to calculate that the total number of people being killed and also injured. We also want to see that how many incidents occurred in Virginia and also in other states. All right, so if you recall that in our lectures, actually there is one analysis that can do this one, which is spatial drawing. So spatial drawing is a very popular spatial data analysis. So we go to the analysis. You can find the tools from this toolbox, or you can just open this window, and where ArcGIS Pro has the most common spatial analysis tools available, that in this window. So let's go ahead and find out the spatial drawing, which is right here. So that's one of the most popular tools. So let's open spatial drawing. So now we need to decide what is the target feature and also what is a drawing feature. So the target in this case will be our population at the state level. we're going to join that one with the mass routine data. So those are the points. And the methods will be intersect, which is fine. And now we go to the fields. So here, because we want to count the total people being killed, so let's select the people that user being killed. And for this merge result, we want the total. Okay, so let's use total. And for the number of people being injured, we also want the total. Okay, we need to change the defines how we want to calculate or aggregate the people being injured and also killed. All right, now let's just run this analysis. And you can see the default name of the output is called State Population Spatial Union. Because we are going to generate a lot of results outputs from those analyses. So the best practice is make sure that you keep a very clear name for all the output. So in this case, spatial union, I think that's perfect. Oh, sorry, spatial drawing. I think that's perfect. So that the result is saved in our geodatabase, and also is also saved in our project, which is also on this map. So if we open the attribute table, we can see that we have the joint count. That means that number of instances that in each state. We also have original information like the total population, name, etc. Because we didn't specify the methods for the incident date and also incident ID, so I believe that normally the first record will be included here. However, we did specify the methods for the number of people being killed, so that the total number of people being killed and also total number of people being injured. Okay, so let's go ahead and also see which state has the most number of the mass routines. So if we just click the joint count, which equals the number of instances or number of the points, we see descending, and we find our state that has most number of instances. And if we want to find out which state has the most number of people being killed, which is Texas, and the most number of people being injured, which is also Illinois. Okay, so here we can find some useful information. All right, and we can also create maps. So here, let's say I'm going to close the mass routines. I will just leave the spatial drawing, and then I'm going to create a map. So go to feature layer, symbology. We are going to use graduated colors. Okay. Or you can use proportional symbol map. So let's use a proportional symbol map, because we are showing the numbers. And for the field, yeah, we are going to use a joint count. I think that's perfect. And we are not going to normalize. And also you can choose different colors. So for example, if you want to use, let's see, let's say I want to use yellow color. Okay. And I can also classify the data. So let's see how many legend count do you want. Let's say I just want 3. Okay, so it indicates 1, 10, or 100. Okay, so that is our map. Okay, and if you want to, let's say, create a more beautiful map or more professional map, you can just check our later labs where we are going to teach how to create professional maps. Okay, so right now I think this map is great. All right, next we can also do some very simple date visualization. let's say that we have those number instances in different states, and we may wondering that, okay, so does the number of population play an important role in the number of the instance or number events? So for example, is that because California and also Texas have larger population, so that's why there are higher number of the instance and the number of people being killed? So if we want to check that out, I think the best way is to do a chart. So let's just go ahead go to our spatial drawing result and right click. And let's say we are going to create a chart. And this time we're going to create a scat plot matrix. So we're going to bring 4 variables into this chart. We're going to bring the number of the instance, which is joint count, the total population in each state, the total people being or victim being killed and a victim being injured. And I'm going to hit apply. I also want to add this trend line so that I will be able to see that how they are associated with each other. And also I'm going to make this one a little bit let's say add more information. So for example, on the lower left, I want to show the scatter plot. On the upper right, I want to see the correlation coefficient. Okay, and now I think it's pretty clear that we do have a very high, strong relationship that between the number of people being injured versus the number of the instance. That is also on this scatter plot. So I think that makes sense. That means that if you have more mass shooting events, there will be more people being injured. So that makes total sense. Let's see how the total population is related. So if we look at the total population versus the number of people being injured, we can see R squared is 0.6. Which actually is pretty high. I mean, just considering that we're using population to explain the number of people being injured. And if you look at people being killed, the R square is 0.62, so that is even higher. So, which does prove that, so if there are larger populations, so if the state has more people, it tends to be more mass shooting events, and also more people will be killed or injured. All right, so let's close this chart and let's do another analysis. So instead of using the spatial drawing, what we can do to get the same result is called summarize within. So if we go to the analysis, the same window, we can see that spatial drawing is the third actually default spatial analysis function. The first one is buffer, and the second one is summarize within. This actually is a pretty new tool. So in ArcGIS Pro, so in the traditional GRS package, for example, in the past ArcMap or QGRS, you may only have buffer or spatial drawing, and you may not have the summarize within. So let's open summarize within. And again, this is a new function that available in ArcGIS Pro. However, I think this is more straightforward. So for example, I want to calculate the number of instances. So let's close spatial drawing result. I just go back to the mass routines and also state population. So again, we want to summarize within each state or within each polygon how many features are there. So we can use spatial drawing. We can also use summarize within. So for the same questions, we can use different tools, and it is really up to you to find out the one that you get comfort to use. So let's say we want polygon to be state population, and the summary feature will be the mass shooting. Again, we have a lot of features now, so make sure that you choose the right input. And the result is summarized within. I think that's perfect. and also which field you are going to summarize. So we are going to count, let's see, the total number of people being killed and also the total number of people being injured. Okay, and also for each of those tools, you can just click this question mark and they will give you a very clear description that which tool, the function or the purpose of those tools. And also for each single input, if you click this information icon, and they will tell you, okay, so what are the input, and also what is a summary field, for example. So what is a summary fields, and they have a lot of detailed information. All right, so now let's run this one, and we will have now another result. So if we just uncheck mass shooting and our state populations, so here you can see we have our second result, which is summarized within. And if we open the attribute table of the summarized within result, and we actually have a similar result table. So we have the number of people total killed and also injured in each state. And also we have number of people, the total number of points, or the total number of incidents in each state. And actually we can compare this result together with the spatial drawing result. So I think the best way to compare is that we go to the map and explore and make sure that we are going to select all the visible layers, which right now are the summarized within and also the spatial drawing. And now let's say we click the Virginia. Okay, and now you can see we have two results. For the summarized within, we have this number, and for the spatial drawing, and we have this number and this number. So those are exact results. And if you switch to a different state, like say Georgia. Okay, so 30108 and 30108. So yes, so they do give us exactly result. Okay, so that is our first question. So we want to see at the state level and how many people being killed and also injured at each state, and also how are those variables being related with each other. So number of incidents versus total population versus people being killed versus people being injured. All right, so let's remove those results. So let's also remove the state population. So let's bring back our county population and also mass routines. And this time we have a different question. So that is within, for each instance, let's say we have instance, I believe, in Harrisonburg. Yes, right here. That is instance in Harrisonburg. Yes, in Harrisonburg. Okay, and also for this Harrisonburg city, we have this population, and for Rockingham County, and we have this population. Okay, so my question is that for this instant, what is a total population within 50 kilometers? What is total population within 50 kilometers? So I want to calculate the total population within 50 kilometers for each single instant. So to do that, there are several ways. The first one, probably is the hardest one, is that we can create a buffer so that we calculate, okay, so what is area of the 50 kilometers? And then we use that buffer to intersect with the county population. And then we summarize, okay, so for each buffer, so what is the total population? And then we join that result back to our mass routing data. Okay, so that's our first approach. So we're going to use 4 different tools. Okay, so let's start. So let's go to analysis, and we're going to create a buffer. And for this input feature, which is mass routine, and the result is mass routine buffer, which is great. And the distance, we're going to see 50, and we want to see kilometers. Okay, so we don't want that to be dissolved because we want each instant has a unique buffer. So let's run this one. And what this one will create is that for each single instant, for example, for Harrisonburg instant, we have this buffer. Okay, once we have this buffer and we are going to count, okay, so what is a population within this region? Okay, what is the total population within this region? So in this case, the population will include this state and this state and this state, but we are not going to count population in this state or in this state. So that is what we're going to do. So now we have the buffers. So next, we're going to do the intersect. So we're going to use the buffer to intersect with our county population so that the intersected result will contain the buffer information and also county population information. So let's go ahead and also find out the intersect, which is in this overlay. And the input will be the buffer and also the county population. For the result, let's call it intersect. Okay, so mass routine intersect, we know that that is a buffer intersect with the population. And now let's run this one. And then we will have that intersected polygons. So if I just first let's uncheck the intersect. So now that is a buffer of each instance, and that is a state, the county populations. The intersect means that we will have the joint locations, that each single joint locations between the buffer and also the county, and then we will have this one. So now we can see within this Harrisonburg buffers we have multiple counties, and if we click each single features, and we have the instant ID and we have the total population. So for this, the same instant ID in Harrisonburg, and we have the population in this county, and again for the same instant we have the population in Rockingham County, and for the same instant we have the population for the Harrisonburg. Okay, so now we have for each instant we have, okay, so what are the covered total populations in different counties, Next, we are going to sum up all those populations. So that tool is called summary statistics. So we go to the summary statistics, which is a second tool in the summarized data. And input table will be the intersect result. And for the output table, we just call it statistics. And then we want the total population. Okay, we want to calculate the total population for each single instant. Okay, so for example, right now for this buffer, we want to calculate all the total population of those counties for this single instant. So which is this point. So for this single instant. Okay, so that's what we want to do. And now let's just run it. So summary statistics does not create a feature, but instead we have this table. So let's open the table. And now we can see that for each single instant, how many counties that are covered within 50 kilometers, and what is the total population. Okay, so now we have instant ID and also total population. However, this is a table, so that's not in our mass routine dataset yet. So we want to join this one to our mass routine dataset. Okay, So to do that, remember that we have done that in our previous labs. So that drawing function is not in this window, so we need to go to our toolbox, and we just search drawing, and we bring this drawing field, and we're going to bring the input table, which is mass routine. We will join with instant ID, and the drawing table will be the statistics, and also the ID will be the instant ID as well. Okay, and now let's just run it. Okay, great. So now if we open the mass routine attribute table, we can see that we have the total population, okay, which is covered within 50 kilometers. Okay, so for each single instant. So if we just check the Harrisonburg, okay, Harrisonburg mass routines. Let's just make a selection. So Harrisonburg, and you can see that is the total population that within the 50 kilometers. All right, so that is the first approach. I know you might be confused. I know a lot of you might be confused because, yeah, that is really a very complicated analysis. It requires 4 steps. By the way, if you go to the history, you will see that all the analysis that we have done in this project. Okay, so this is also a good feature that, so if you just click one of those analyses, it will bring you the configurations of those previous analyses. If you want to run it again, or if you want to figure out the errors, you can go to history and also find out those previous analyses. All right, so that is the first way to answer that question. That is how many total population within the 50 kilometers of each single instant. And we do have an easy way. Okay, so let's remove the intersected result, the buffers, and also the table. Let's bring back our county population and also mass routines. So what is the easy way? So in the ArcGIS Pro, so there's a new function called summarize nearby. Okay, so we have the summarize within function. We also have a function called summarize nearby. So let's open the toolbox and search summarize nearby. Okay, and bring that one. So this will do exactly what we want to do in ArcGIS Pro, but it just requires one single step. That is, we want to summarize the information of the nearby features. For more details, you can just click this button and also just go to the website and I'll check the details. But in this case, let's use summarize nearby. We want to summarize for the mass routine data, and the input data will be the county populations and output feature class. So let's choose the summarize nearby as the output. And you can choose a different type of distance, which is a very nice feature. So you can choose driving distance, driving time, walking distance, walking time, or just a straight line. So I will use a straight line. However, keep in mind that this tool may use the ArcGIS credits. So, for example, if I'm using the driving time or walking distance, etc., it will require additional dataset that behind this project on ArcGIS. So it will cost additional credits. So just be cautious of using those tools. So it's a very nice tool that you can use, very simple, but it can be expensive. All right, the distance, let's use 15 kilometers. And what are the fields you want to summarize? Okay, I want to summarize the total population. Okay, so for each single instant or each point, I want to summarize the nearby populations within 50 kilometers. Okay, so sounds familiar? Okay, let's run it. This one can be slow because my guess is that they are doing a lot of calculations in the back end. So actually, if you view the details, okay, and you can see that my guess is that they are also creating those buffers, okay, or do the intersections, etc. So because the output actually is also a buffer, so it is a buffer. So we did buffer manually, but summarize nearby calculate buffer for us. All right. You can see now it's finished. It took like almost 1 minute, and so to finish this analysis. And now there's a result of summarized nearby, and you can see that they also create buffers. Yes, they are using buffer MacGuess to do the same analysis. So if we open it, we can see here, you see they create buffers 50 kilometers, and those are the summarized total populations. Okay, and you can see that this result is slightly different from our results. Okay, so this result is different from our result. Let's see if we can find out Harrisonburg. So yeah, I'm just curious to see how this one can be different. So let's select it, Harrisonburg. And you can see there's a huge big difference in those analyses. Okay, so I searched online and I was trying to find out why there's a difference between the analysis we performed manually, so like 4 steps, versus this analysis, and I couldn't figure out why, because in ArcGIS Online website they didn't tell too much details. So if you are interested or if you know the difference, please leave comments below on this video. So I think that's I'm just curious to see why they are different. All right, so that is a second approach, and unfortunately we have the third approach, which is probably the easiest one. Okay, so the third approach means that, okay, so let's say we have the mass routing data, and but we don't have the population data. Let's say we don't have the population data. We have the mass routing data, and based on that data set, I want to calculate what is the total population of each instant within 50 kilometers. Is that possible? Yes, it is. And that function is called Enrich. So if you go to Enrich, okay, and you just need to provide your input data, and also just remember this will be more expensive because in this analysis, if you go to add variables, and you can check and select different variables that are available on ArcGIS Online, like crime, income, population, etc. So for example, I want the total population. And now you can see we do have the population that in different years. So I can check that one and click OK. So now you can see this variable has been added. So it's very, very convenient. You can even add other variables if you're interested. For example, I want the household. Okay, median household income, and what you need to do is just search and also check, and click OK, and that variable will also automatically added by this analysis. And again, this is not free, so it will cost a few credits. Okay, so I'm going to uncheck the household income. I just want to see what is total population. So normally for this input feature, you may want to choose mass routines. So if you choose mass routines, the total population data will be added to your mass routine data. So that's what we normally do. And similarly, I can choose, do you want the straight line, driving time, walking time, etc. So what you can do, you can say, okay, I want the 50 kilometers. Okay, so you can do that. However, because I am curious, I want to compare the result of the Enrich against summarized nearby and also against the previous result that I used the buffer intersect. So in this analysis, I'm going to use summarize nearby as the input. Okay, which means that I'm going to summarize for each buffer. And within each buffer, I want to know what is the total population. So that's what I want to know. So I want to say that, compare that against the Enrich. And now you need to estimate how many credits will be used. 6.4. That's fine. And let's just run it. And let's look at the details. Okay, and hopefully we will not have any errors. All right, so it took like 30 seconds, and now it is success. So now we have a new feature called Enrich, and if we open the feature, and now we have the result. So here, this is the result from our very first analysis. So by using buffer, intersect, etc. And this is the result by using the summarize nearby, which they also calculated these buffers with 50 kilometers. And then we go to the very, very right. And now that is the result from the Enrich analysis. So Enrich analysis calculated that within each buffer, so the same buffer, what is the total population. Okay, so now I think I want to compare the result from those three analyses or three functions. So I'm going to just right click the Enrich results, and I'm going to create this scatter plot matrix. So here let's choose this one, that is the first analysis. This is the second analysis, so where the SM is a lowercase, and also total population, that is the third analysis. And we hit apply. Let's add a trend line, and let's also add R square. Okay, and you can see the R square is pretty high, so which means that the data is pretty consistent. So R square, and especially if you compare this one, which is if I remember right, and this is the result from summarize nearby, and against the Enrich. Okay, so we can see the R square is 0.94. And if you look at this one, that is buffer against Enrich, R square is 0.91. If you look at this one, that is buffer versus summarize nearby, the R square is lowest, that is 0.83. Okay, so I would say that the dataset gave pretty much the similar result. So statistically, I don't think that will be. I think we can use either of any of them. So, but I think it's really up to you to figure out which one is the best results in your project.